Hey guys, welcome back to another Default Cube CG Matter tutorial, and today I'm going to show you how to make some procedural mazes, which you might think is hard because it looks like something that would take a lot of nodes, but in fact it isn't. It's not hard, and I just woke up for this tutorial, so if I look like I'm dying, it's because I am. So, what are we going to be making? I made this material, which you see kind of looks pretty cool, but it's procedural meaning I put some sliders. So the first one is kind of like the size of the maze, meaning we can make it any size, have an arbitrary amount of detail. And then the second one is kind of like a seed value, but if we bring it enough to one direction, it's going to give order, and the same for the other direction. But in between, it just creates new mazes. And for the people who are hardcore math nerds, I don't think these are solvable mazes. There's no start and end, and in general, they're not solvable. Like if you start going here, I think you're going to run into an issue eventually. Maybe not. Either way, yeah, so it doesn't take that many nodes. In fact, for people who aren't used to the shader editor, you're like, what are you talking about? There's like 10 nodes there. 10 is nothing. So how are we going to make this with only a few nodes something so complicated? So before we start, I just want to talk about the basic idea. Even though this looks confusing, I want you to notice that there's only two types of lines in this maze. There's lines that go diagonally this way, and there's a lot of those. About half of them are that. And then the other half are lines that go this way. So really all we have to do is create two lines, one that goes like this, one that goes like this, and start randomly scattering them, and it's going to look like a maze. I'm not doing any complicated math here. So let's start with a new Blender scene. Control-N, General, don't save. If your Blender, let's go full screen. If your Blender looks like mine, that means you didn't do anything weird to it. But yeah, this is what you should be seeing. And what we want to do is we're going to replace the cube with a plane. Although this maze works on arbitrary surfaces if you use UV mapping, but we're just going to use a plane and put our maze on here. So add a plane. Go to shading, since we're just going to be doing material stuff. I do like recording tutorials in the morning. It makes my voice deeper. I don't need to think about anything because my brain's so foggy. But either way, what we're going to do is we're going to create a material. We're going to call this maze. And this is a material that works in EV or in cycles because we're just using black and white grayscale stuff, so we're going to use EV since it's faster. So we do not need the principle to be SDF, at least for now, and we're going to start off by making one line that goes like this and one that goes like this. So how do we do that? Well, we're going to start off with texture coordinates since we need to know where spots on our plane are. So let's hook that up to the surface. So this is a vector generated coordinates. I'm not going to go all the way into it, but we want to separate it into its x, y, z components. So separate x, y, z node. So you can see with our x component, we're going from left to right. By the way, I'm going to explain every step because I feel like that's the thing to do. X goes from left to right, so this is 0 on x, and this is 1, and left to right. Y does the same thing, but up to down, and z is, this thing has no depth, so it really doesn't matter. So the question is, how do we turn this into that diagonal line? Well, there's a bunch of tricks, but since I'm using Blender 2.82, it's gotten a bit easier, and I'll show you how. We're going to add a math node. And we're going to set it to compare. And I'll explain what this does in a second. I'm just going to bring up the third slider. What this is doing is it's looking at our x value, comparing it to the second slider, so x compared to 0.5, and it's going to be white if it's within in this case, 0.05 difference, and black elsewhere. So if we make this bigger, more of the thing is going to be white because we're comparing it to this with a much, much more lax tolerance. It just needs to be 0.34 away. Whereas with 0, it's not going to have anything because nothing can be, there should be an infinitely thin line here. But we could just give that a bit of thickness. Right? And if we change this, we're going to compare to let's say 0.4, which means we're sliding to the left because 0.4 is over here and vice versa, all that. So now we have a line. We need to make it diagonal. We could do some complicated math, or we can rotate. By the way, 2.83 has a vector rotate node. This doesn't. At least I don't think so, so we're not going to use it. But instead, if you have the vector rotate node, that's the one you want to use now. But instead, we can just use a mapping node, and we're just going to rotate on the z-axis. Something like 45 degrees, and that's now diagonal, but we want it from corner to corner, and without getting too complicated, you just slide to compensate. So we're just going to find, it should be 0.5, I think. 0.5, we're not going to go over why it's exactly 0.5, but it is. So in other words, what we've done is we've taken texture coordinates, rotated them, and shifted them a bit, Then we separated the x component and used this compare function, which is much nicer than the other way you do it, which is with some absolute values and color ramps and all that. Okay, so now we need to make the other. So take this, duplicate it. And we're also going to use generated coordinates. And let's view this one. By the way, if you're wondering how I'm going back and forth, and for the people who already know, I'm sorry I mentioned it every tutorial, this is a Node Wrangler feature. If you don't have it, go to Edit, Preferences, Add-ons, type in Node Wrangler, and enable it. Comes with Blender, just not enabled. So you can hit Control-Shift-Click on any node and it will become viewed. So for this one, what we want to do is rotate it the other way. So instead of 45 degrees, other way, minus 45 degrees. Which means we also need to compensate the x location, and in this case, I don't know what it's supposed to be, maybe minus 0.25, but we're just going to slide it until it looks right, because I don't really care about precision here. So something like that, you can figure out mathematically what it's supposed to be, but now what do we have? We have a diagonal line and then one going the other way. And what we want to do is first tile them so that there can be many more in our plane. And then we just kind of want to randomly say, here have we'll call them, I don't know, it's kind of hard to describe. It's not like a horizontal versus vertical, but let's just call it that. So we just want to randomly distribute horizontal and vertical lines, and it's just going to look good. So first of all, how do we do this tiling? Well, it's a very simple texture coordinate manipulation, and since we already have all this set up, I'm just going to hold Shift, right, click, drag, and just connect this so that we have one generated going to both of these in a more organized way. And we're just going to do a simple manipulation before it even reaches our mapping coordinates so that we can start tiling. And there's a very easy trick for this. There's a bunch of ways to do it. But what we're going to do is we're going to add a vector math node, which is going to alter our generated even before it does our rotation is the way you want to think about it. And we're going to scale this, meaning it's going to scale up, which will make this look smaller. We're going to scale by, I guess we could just slide it in here. Something like, I don't know, 5, 10, doesn't matter. This doesn't make a tile, but if we add another, so the way you want to think about this, is now instead of going from 0 to 1 on each axis because it's generated coordinates, now we're going from 0 to 5 because we scaled it by 5. We're going to take this, and now we're going to add a fraction operation, which does exactly what we want. And you're thinking, okay, then that's easy, but why does it work? Again, normally generated coordinates on x-axis go to 0 to 1, 0 to 1, but with scale of 5, it's like multiplying by 5 kind of in the vector sense. So now we're going from 0 to 5 to 0 to 5, and the fraction says whenever you go above 1, just start rounding, as in if you have 1.1, just make it 0.1. If you have 2.3, make it 0.3, which means instead of going from 0 to 5, we kind of have 5 rounds of going from 0 to 0.9999999. And that's why it tiles very nicely. And you can imagine what the other one's going to look like. It just tiles this one. And you may be thinking, oh, looks pretty good, but I want to get rid of these kind of blank areas. There's a way to do that, but it's not important. In fact, this method doesn't have to be with diagonal lines. It can be with anything. But, okay, we now have tiling. And what I was going to do before is I was going to make a value node that lets us control this outside of the node. So 1, 4, and you can see 4 is 1, 2, 3, 4, and same thing vertically, 6, etc. And we can make this a bit, I was going to say we could make it round, so we can't have something like, 7.5, but I guess it's fine. Okay, cool. So now how do we make it randomly choose which one it wants? Well, I've done it before where you do a lot of math to do that, and honestly it sucks, but there's actually a very, very convenient trick that doesn't require any effort, and that is adding a brick. Don't see people using brick too much. Brick texture. Let's view the brick. So this is what brick texture looks like. It's made to make brick walls and stuff, but nobody ever uses it. So what we're going to do is we're going to repurpose it in a way that basically creates a bunch of tiles at the same size as our tiling before and then randomly assigns one or the other. So first of all, we want to get rid of this kind of like offset where it's like 50% offset every line of bricks. So let's just get rid of that offset. Next, we want these to be square. So brick width and height, I'm just going to make 1, or you can make them both 2 or whatever. 1 is the one that mathematically makes everything easier. Next, we want to get rid of these lines in between, which is called mortar. Mortar size, make that 0. And you can see now we've kind of generated a method to divide our plane into cells dictated by the scale, how many cells we have. and it randomly assigns a number to each cell, which is exactly what we want. And notice, if we kind of avoid all this, we just view our texture coordinates tiling, what we set up is a way to make our texture coordinates tile, and you're going to notice that this looks very, very similar to this. In fact, we want it to have the same number of tiles. So the reason I kind of separated this value is we want to use the same size. So I'm going to take this, and it's going to be kind of hard to see, so let's move it closer. I'm going to take this and use this for our scale. So it should have the same number of tiles for the brick and the same number of tiles for the tiling, you know? Okay, cool. So now how do we use this to mix stuff together? Well, we can take these two, which again are our vertical and horizontal lines. We're going to mix them together, which, you know, you could add a mix RGB, or there's a fast way to do it, like that. And that was Control Shift right click drag. We're just mixing these together. Let's view it in the surface. Right now it's going to look like crosses, because what we've done is we've taken this and mixed them together. So when you kind of mix those two together, you get both of those components. And this is a nice way to make this kind of design, by the way. Okay, cool. And also, if we make the factor 0, it's going to be only our, let's say, vertical, another way only our horizontal. But we want our factor to be per cell, which is exactly what this brick texture is. So we're going to take this. Again, all these nodes are too small. We're going to take this and make this our factor, which you can see kind of does the trick, but it's kind of like each one is kind of somewhat transparent on either the vertical and horizontal, and those transparencies are different. If you understand what I'm saying, we want an all or none. We want it to be either vertical or horizontal, not just 30% horizontal, right? It needs to make a choice. In other words, this thing can't go from like white to gray to black. It needs to either be white or black. And we can do that by adding in a math node, and there's a bunch of ways to do this. This is just the easiest, and we're going to set this to greater than. And this does the trick, because it's saying at each cell it's going to check if it's bigger, greater than 0.5. If it is, make it white. If it's not, make it black. So we've gone from something that has a bit of variation to something that is binary. It's black or white. And because this whole thing's procedural, you make this bigger, it's going to look like a giant QR code. Okay, so now we are going to take this and use it for the factor. Again, it's an all or nothing response. So let's view that. And there you go. You see, now we get something that looks much more interesting, and it works with scaling. And this technique, it's called like trebuchet. I don't know what it's called. There's a name for this technique of basically scattering very simple elements to make something much more complex. So it doesn't have to be vertical and horizontal lines. It can be like semicircles or whatever, and it creates very interesting designs. But you can see this is a nice way to kind of approach making a maze with something that isn't that complicated. We just have two components. Okay, so that takes care of making the maze at any scale. But how did I, kind of change the seed? Well, I guess there's a couple ways to do this, but since we're driving this with a brick texture to say where do we want it to be, one or the other, it makes sense to use this bias slider. So you can see we move that. If the bias is bigger than 0.5, it's going to pick only one of them, because if we see this, it's going to be all white or all black. Yep. And if we change this to minus 0.5, it's going to be all white. So it's choosing the same thing every time. But anywhere in between, you kind of get these different options, which again, looks like this. So this is kind of our seed, and the nice thing about it is we can have it be all one or all the other, or if you want something in between, just keep it in between. Okay, cool. I'm trying to think what more we can talk about. Well, note that we use the compare node to generate these, meaning that if we add a value to, remember, this is the number we're comparing it to, which is 0.5, doesn't really matter, but the second one is the kind of, or I guess the third one is the tolerance, in other words, the thickness. So we can add a thickness to both of these. Already that's a pretty cool design. But we add it to both of these. Let's set it to something low. We get back our original maze, but we can also control the thickness of the maze. So really thin looks cool, really thick looks cool. So that's that. And since, again, we're just choosing between both of these, we can always change what one of our choices looks like. So if we drift, it's going to look bad, but if we drift it, you see it's moving half of our components. And this is a cool design in itself. It kind of looks like a star field. You can use that for a tutorial or something ducky. But Yeah, how do we package this into a node? Because I feel like we've gone over the fundamentals. Well, first of all, we want to understand what it is that we want to control. Well, we definitely want to control the scale. I think we'd probably want to control the thickness. Again, this is the compare thing that we attached. So we're going to add that. And by the way, shift right click drag to make that a bit nicer. I would also like to control this bias, which kind of is our seed. There are ways to make it more like a normal seed because this kind of behaves weirdly, but it's fine. And I think that's it. I mean, we could add a bit more control, but I think that's fine. So I've taken my 3 value nodes, put them off to the side. We're going to highlight everything else except for the material output, Control G to put it in a group. And in fact, we don't really need these value nodes since we can just control it from here. But now we have a single node that should do all of it. So I think the first input is the size, the second input is the bias. So let's try changing the bias. No, the third one's obviously the bias. Okay, so there's our bias. Now we want to make it a bit bigger. Forget which one's which. I think the issue is one of these is thickness. And there we go. If we made our thickness too big, it would have made everything white or everything black. So it probably makes sense to name these, which we'll do in a second. But it looks like this first one is our thickness. The second one is our scale, and this third one is our bias, which kind of works like our seed. So I'm just going to rename these, if I remember how to do that. So select your node, hit N, and then in the, how embarrassing would it be if I can't remember how to do this? I think we have to go into the node itself. Actually, I'm pretty sure of it. Okay, so we hit this, we go into the node options, somewhere here. Here we go. And you can see that we have our 3 inputs that we can now name. So the first one was thickness. The second one was size, which is the size of our maze, and the third one is bias, but we can just rename it to seed. And we can give these default values and everything, but that's fine. So now if you send this node over to somebody, they're like, oh, thickness, size. I don't need to know what I'm doing. I'm just, changing these values around. And there you go. I hope you enjoyed this tutorial. I think it has very good concepts, and you can use this to make a procedural like hedge maze or something like that. So this is just kind of how to make the underlying pattern. But what you want to do with this is entirely up to you. And you can always change this from generated coordinates to UV coordinates and then have this on the surface of a sphere or whatever. But yeah, I hope you enjoyed this tutorial. If you did, the best way to support me, really the only way to support me, is by donating over at my Patreon. It is my most consistent form of income, so I kind of rely on it. So if you want to keep these tutorials coming, that is the best way to do it. But of course, you do get benefits beyond just the donation, which is stuff like certain channels on Discord. You get early access to some tutorials, private access to others, and definitely behind the scenes information for all of them. But really, it's just a donation to help me out. So if you are in a financial position where you can do that, I would greatly appreciate it. But otherwise, I hope you enjoyed this free tutorial. This was a pretty good one. I think I'm going to start recording them in the morning. Yeah, hope you enjoyed it. See ya.